One is upcoming. Showing like very showing your screen.
Hello? Hello and good evening, everyone.
I think this is
Hello. Hello and good evening. Everyone. Good evening and welcome, everyone. We're sorry for those technical issues and we trust that they are sorted out. So we continue with the lecture of today. Today we'll be looking at DC circuit theory. Taking you through this lecture is Engineer Binoba Charles, lecturer, Federal University of Petroleum Resources, Efru, Delta State. What is DC circuit theory? DC circuit theory is the study of electrical circuits where current flow in only one direction. So you can see your electrical circuit and you can see the direction of current flow. In reality, electrons actually flow from your negative to your positive. But for conventional current flow from positive to negative. So for simplicity, we are going to use the conventional flow of current. So I'm going to assume that current flow from positive to negative. So there are some basic terms that is very important we understand so that as we go through the lecture, it will be clear. And one of them is current. What is current? Current is the movement or flow of electric charge in a closed circuit and is measured in amps. So you can see the flow of electric charge in this particular circuit. So as we said earlier, electron actually flow from negative to positive. But we are going to accept the conventional method, that is current flow from positive to negative. So the unit of measuring current is in ampere. And the instrument used for measuring the current flow in the circuit is an ammeter. So resistance. Resistance is the capacity of a material to resist or prevent the flow of current within a circuit. It is measured in ohms. So this is the Greek word, either I call it ohms or omega. And these are different symbols for resistors. We have the fixed resistors. This one is the IEC symbol and this one is the IEEE symbol. we have the variable resistors, usually referred to this the symbol, and we have a variable resistor referred to also as the rheostat, and we have the light dependent resistors, which is also referred to an LDR. Then we have your voltage. Voltage is the potential energy of an electric supply stored in the form of an electric charge. It is measured in volts. Measured in volts. Voltage can be thought of that pushes the electron through a conductor. So like we said, we have a resistor in the circuit. As the current tries to flow in the circuit, the resistor tries to resist that particular flow. So the voltage is that force that pushes the electrons, pushes the current through the circuit despite the resistance that is being offered to its flow. So the greater the voltage, the greater the ability to push electrons through a circuit. Measurement of current, voltage, and resistance in a circuit. So this is a DC circuit. You can see your voltmeter, you can see your ammeter, and you can see your ohm meter used for measuring your circuit resistance. So to measure your voltage in a circuit, you place one probe of the ammeter on one point of the circuit and you place the other on the opposite point of the circuit. So you try to place it in parallel with the source or the device in which you want to measure the voltage. So you place it across the component. While for current, what you need to do, that particular line that you want to measure the current flowing through, you break the line into two. Just create a simple cut. Then put the probe of your ammeter on one side, put it on the other side. It's going to measure the current flowing through the circuit. And also to measure the resistance, all you need to do is to connect your ohm meter across the resistor and to tell you the resistance of the circuit. So I've looked at three basic parameters. We have the resistance, the voltage, and the current. In order for us to understand these three parameters better, they are being governed by the law which is referred to as Ohm's law. What is Ohm's law? Ohm's law states that at constant temperature and the electric current flowing through a fixed linear resistance is directly proportional to the voltage applied across it and inversely proportional to its resistance. So this is Ohm's law. Current I is equal to voltage all over resistance, and again the unit is in amps. The electrical power. Electrical power, usually referred to as P, in a circuit is the rate at which electric energy is absorbed or produced within a circuit and is measured in watts. So power P is equal to voltage times current. Power in watts is equal to voltage times current. Power also can be equal to voltage square divided by resistance. Also, power can be equal to current square times resistance. So let us look at a simple example to understand Ohm's law. Using Ohm's law, calculate the current I and the power P around the circuit. So your current I is equal to voltage divided by resistance. So in the question, you have your voltage to be 24 volts and your resistance to be 12 volts. So by the time you divide this by this, you are going to get your current as 2 amps. Also, power P is equal to V times I, which is voltage times your current. So by the time you multiply your voltage 4 volts by your current 2 amp, you are going to get your power to be equal to 24 watts. 24. Connection of resistors. There are 3 different methods used in connecting resistors. Resistors are either connected in series, in parallel, or in series parallel. Resistance in series. Resistors are said to be connected in series when they are chained together in a single line. Resistors are said to be connected in series when they are chained together in a single line. So you can see resistors, resistor 1, resistor 2, and resistor 3. They are all connected together in series. So for you to calculate the equivalent resistance of resistors connected in series, all you need to do is to add the individual resistances. So your total resistance in this circuit, ROT, is equal to RO1 plus RO2 plus RO3. So by the time you add this 1 kilo ohms plus 2 kilo ohms plus 6 kilo ohms, you are going to get your total resistance of 9 kilo ohms. Resistors in parallel. Resistors are in parallel when they are connected to the same 2 points or node. So you can see this resistor is connected to this node, connected to this node. This one the same thing, the same thing. This same thing, this the same thing. So when resistors are connected like that, the equivalent resistance is given as 1 over ROT is equal to 1 over RO1 plus 1 over RO2 plus 1 over RO3, and so on and so forth, depending on the number of resistors connected in parallel. So you can see different nomenclature of resistors connected in parallel. You can see this resistor A and B, they are connected in parallel. You can see A, B, C, D, they are connected in parallel. You can also see A, B, C, D, B, C, they are connected in parallel, and so on and so forth. So let us take this example 2. Find the total resistance ROT of the following resistors connected in parallel. So I have 3 resistors connected in parallel. RO1 is equal to 200 ohms, RO2 is equal to 470 ohms, and RO3 is equal to 220 ohms. So by the time we do that, the total equivalent resistance is equal to 1 over ROT is equal to 1 over RO1 plus 1 over RO2 plus 1 over RO3. So the first thing we need to do, we take this 1 over 200 plus 1 over 470 plus 1 over 220. So by the time you do this arrangement, you are going to get the total for this particular part as 0.0117. But now we have 1 over ROT is equal to this. So only your ROT will now be equal to 1 over this. So you are going to have 85.47 ohms as your total or equivalent resistance. But the case is different when you have only 2 resistors connected in parallel. So if 2 resistors are connected in parallel, the total resistance ROT is equal to RO1 times RO2 divided by RO1 plus RO2. So if you are working with only 2 resistors, there is no need trying to go through that initial formula. Just say ROT is equal to RO1 times RO2 all over RO1 plus RO2. But note, this formula only applies when resistors connected in parallel, they are just two. So we look at another example. They say find the total resistance ROT of the following resistors connected in parallel. Again, since there are two resistors connected in parallel, one is 22 kilo ohms and the other one is 47 kilo ohms, all we need to do is just to say product all over sum, which is 22 kilo ohms times 47 kilo ohms divided by 22 kilo ohms plus 47 kilo ohms. And when we do that, we have approximately 15 kilo ohms as our equivalent resistance. Example 3. Using Ohm's law, calculate the current I and the power P around the circuit. So you can see this is another circuit. The input voltage is 12 volts. We have 4 resistors. These 2 resistors, they are connected in series in parallel with this particular resistors. So the first thing you need to do in trying to look for the total current flowing through the circuit, you have to look for the equivalent resistance of the circuit. So like we said, R02 and R03, they are in series. So since they are in series, R02 plus R03 will be equals to 12 volts. That is 8 plus 4 will give us 12 ohms. So when you add up these two, you are going to have 12 ohms. So this is exactly what you are going to get. So you now have another circuit whereby we call this one now arrow A. So arrow A is now in parallel with arrow 4. So we resolve these two resistors in parallel. And when we do that, we use the equivalent resistance of that. We are going to get our resistance of arrow A and that as 6 ohms. So by the time we put the 6 ohms in this circuit, we now notice that these resistors, arrow 1 and arrow combination, they are now in series. So all we need to do is just to add both of them together to get our equivalent resistance as 12 ohms. So for that entire circuit, the total equivalent resistance is equals to 12 ohms. So after getting the total resistance of the circuit, the next thing is to apply Ohm's law to calculate your current. Apply Ohm's law to calculate your current. So your current I is equals to voltage all over resistance. Voltage all over resistance. So your current I is equals to 12 divided by 12. So by the time you do that, your current is equals to 1 amp. Your current is equals to 1 amp. Current divider rule. A current divider is a parallel circuit in current divides among a number of parallel connected paths called branches. So when you have a parallel circuit whereby your supply current divide among a number of parallel connection paths, they are referred to as a branches. In those branches, they have different current flowing through, and the voltage applied to different points varies. So that is exactly what we want to study using the current divider rule. So the current divider rule is basically used to look for a current flowing in a parallel path. So let us see this circuit for example. This is the voltage source and this is the total current flowing into the circuit, IT. When the circuit gets to this point, since these two resistance they are in parallel, to divide, so I arrow 1 flows through this resistor arrow 1, while current I arrow 2 flow through this resistor arrow 2. So look at what the current divider says, that if you want to look for the current, flowing through resistor arrow 1, which is I arrow 1, you take the total current IT, multiply it by this resistance divided by arrow 1 plus arrow 2. Take note, if you want to look for the current here, you take the total current flowing in the circuit, you multiply by the other resistance and you divide it by arrow 1 and arrow 2. Also, if you want to look for the current I arrow 2, if you want to look for the current I arrow 2, you also take the total current IT, multiply it by arrow 1 and divide it by arrow 1 plus arrow 2. So that is exactly what the current divider rule states. And when you have more than one resistors connected in parallel, the process is actually different. So this process is actually used when there are only two resistors connected in parallel. But when there are more than one, the process is different. We'll get to that. So let us take a simple example like we did before. To calculate the current IT and the current I1 and I2. So as usual, as we did before, when we calculated the total current in this circuit, we got our total current to be equals to 1 amp. That's the total current flowing in the circuit. So now, the current here now, we agree that is 1 amp. So since this resistor is in series here, it is this total current 1 amp that will flow and get to this point. Once it gets to this point, it will through this 12 ohms resistor and part of it will flow through this 12 ohms resistor. So the question now is that what is the value of the current flowing through this 12 ohms resistor? So all we need to do, since there are only two resistors connected in parallel, we apply the current divider rule. So I arrow 1 is equals to IT arrow 2 all over arrow 1 plus arrow 2. Like we said, if you want to look for the current here, you take the total current IT multiplied by this particular resistance divided by the two resistance. So when we do that, we're going to get 0.5 amps. Also, to calculate the current flowing through here, which is I2, we can call it I arrow 2, will equal to I total divided by arrow 1 plus arrow 2. So when we do that, we also have 0.5 amps. So the reason why we are getting both of them 0.5 is because the two resistors they are of the same value. So that means the current will divide into two. Part of it will flow through here and part of it will flow through here. Okay, so like we said, when the resistors connected in parallel, they are more than two, we cannot use that simple law to analyze it, but rather we can use this other equation to analyze it. So how do we do that? For you to look for the current flowing through I1, all you need to do is to look for the total current flowing in the circuit and multiply it by the equivalent resistance of all these resistors in the circuit, and you divide by arrow 1. So with that, you're able to calculate the current flowing in I arrow 1. Also, to get the current flowing through I arrow 2, we take I2 equals to I total, the total current flowing in the circuit, multiplied by the equivalent resistance. Then we now divide it by the resistance of arrow 2. So we'll continue the process until we have calculated all the current in each of the branches. So example 5, find the total current IT and the current through each of the resistor. So we see your voltage source is 50 volts and we have arrow 1 2 kilo ohms, arrow 2 5 kilo ohms and arrow 3 10 kilo ohms. So again, for us to do this analysis, we calculate the equivalent resistance. We calculate the equivalent resistance. Again, our equivalent resistance, 1 over arrow equivalent is equals to 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3. So by the time we put in the values and do our calculation, we are going to get our total equivalent resistance as 1.25 kilo ohms. So that is your equivalent resistance of all these resistors connected in parallel. Now, the next thing for you to do is to calculate your total current. So, according to Ohm's law, I is equals to V over R. So, by the time you do that, you are going to get your total current as 40 milliamps. 40 milliamps. So, the next thing for you to do now is to calculate the current flowing in each of these branches. That is IR1, IR2, and IR3. So IR1 again is equal to I total times R equivalent divided by R1. So I have 40 times 1.25 divided by 2 kilo ohms. By the time you do that, you are going to get your IR1 as 25 milliamps. Also, IR2 is equal to this, and by the time you do that, you are going to get your current as 10 milliamps. Thus again, R3 is equal to IT, R equivalent divided by R3. And by the time you do your calculation, you are going to get your current value as 5 milliamps. Example 5. Calculate the equivalent resistance in the circuit. Calculate the equivalent resistance in the circuit. So as you can see, this is a circuit made up of only resistances. Made up of only resistances. So we are told to calculate the equivalent resistance in the circuit. So all we need to do is to look at the circuit critically to know the parts that are in parallel and the parts that are in series. So like we can see, resistor R8 and R10, they are in series and in parallel with this. So we'll start to do our analysis by looking at that. So solution. So like we said, resistor R8 and R10, they are in series and in parallel with R6. So the first thing you need to do is to resolve the two resistors in series. So by the time you do that, your R8 plus R10 will give you 12 ohms. So that means you have 12 ohms in parallel with 6 ohms. So by the time you do that, your equivalent resistance, RA, we can call the new resistance RA to be equals to R9 plus times R8 plus ROD, which is the two resistors in series, divided by all the individual resistance, which is R9, R10. So by the time you do that, just like saying 6 times 12 divided by 6 plus 12. So by the time you do that, you are going to get all this resistance you have here to be equals to 4 ohms. So by the time you get that, you now get a new circuit that look like this. So you have your 4 ohms now in series with your 7 ohms. Your 4 ohms now in series with your 8 ohms. So this and this are in series and in parallel with this. To resolve these two in series first, we are going to get 12 ohms. And now after doing that, you now take them in parallel. So again, we get a new resistance we can call ROB. So ROB is equal to RO6 times ROA plus RO7 divided by RO6 plus ROA plus RO7, which is the same as saying product over sum, which is equal to 6 times 12 divided by 6 plus 12. And by the time you do that, you get your ROB as 4 ohms. So after resolving this, you now have another circuit whereby, which is this, you now have your ROB in series with RO5 in parallel with RO8. So again, you resolve ROB and RO5 together in series. When you do that, you are going to get your equivalent resistance of 8 ohms. Then you now resolve it in parallel with RO4, which is 8 ohms. By the time you do that, you have ROC is equal to 4 times ROB plus RO5 divided by RO4 plus ROB plus RO5, which is equal to 8 times 4 plus 4 divided by 8 plus 4 plus 4, which is the same thing as saying product over sum. So by the time we do that, we are going to have 4 ohms as our equivalent resistance. So after doing that, you now have another circuit whereby this arrow C and arrow 3 they are now in series in parallel with arrow 2. So arrow D is equal to arrow 2 times arrow C plus arrow 3 divided by arrow 2 plus arrow C plus arrow 3. So by the time we resolve that, we are going to have 8 times bracket 4 plus 4 divided by 8 plus 4 plus 4. Our total resistance again now be equals to 4 ohms. So everything about this particular resistor arrangement will be equal to 4 ohms. Then we now have our final circuit where arrow D will now be in series with arrow 1. So by the time we resolve that again in series, we are now going to have our equivalent resistance as 10 ohms. So you can see that we have been able to break that particular circuit into smaller versions in order for us to calculate the equivalent resistance of this circuit. So let us look at a very important case, which is this case. So this is a circuit, like you can see, just a little bit similar to what we had before, but now we have a connection point here. So I want you to look at this particular question and drop your answer at the comment section. Hopefully, when we come back, we'll look at how to analyze it. Then from there, we'll go into the basic circuit theorem law. That is Kirchhoff law, mesh analysis, nodal analysis, superposition theory, Thevenin theorem, and 1 or 2 other theorems that will be very important for us to study under DC circuit analysis. Thank you for watching and have a very great day. So if you have any question, you can leave your question on the comment section and I'm going to respond to all your questions. So thank you. I will respond to all your questions at the comment section. Thanks for watching.